Hi, I'm Jason. Thanks for tuning in. Today we're going to be unboxing the brand new Tevo Flash. So the Tevo Flash comes in a couple of configuration options. We've chosen the BL Touch. We've chosen dual lead screw for the Z axis. And this one has the Trinamic TMC 2100 drivers. So this is basically the top of the line model that was available at the time that we ordered. It's a small box, but it's extremely dense and packaged as well as you would expect. So we have some bits, a scraper, which again is not sharpened, Allen keys, USB cable, it uses a printer style USB connection instead of the mini USB. The manual, which is nice to see. Got a collection of couplers, a belt. This appears to be the tops for the lead screws with the bearing in them. Some PTFE tubing. There we go. Got the brackets for the Z axis, it looks like. So it looks like there's going to be a little bit more assembly than something like a CR10 or more along the lines of an Ender 3 type level of assembly. Some more 2020 and more. Actually, those are 2040s. And this is the all-in-one base. So instead of having a separate control box, it's built into the bottom of that unit. Here's two cooling fans on the hot end assembly. There's the X carriage. There's an extruder, which looks like a Titan extruder. Two motors, probably for the Z axis. A couple long M3 screws. And there is a piece of some sort of a bracket loose in the box here. Looks like that's it. So I took a couple minutes and took a quick look at this little bracket. It appears like it's one of those clamps for a BNC connector. So I went around and found one of the connectors for the hot end assembly here is missing the BNC connector. Little clamp that's supposed to clamp onto the wire, or at least the wire loom. Not that they seem to be doing anything, because this one's not even clamped onto either the heat shrink they put here or the loom or anything, so it's not really acting as a strain relief at all. It's just flopping around there. But that's what that's from, and there's only one of the two screws required to screw it back on, so I'll have to try to find a really tiny screw to screw it back on, or kind of like I said, it's not really providing a lot of benefits, so maybe I'll leave it off for now, but that's kind of an annoying thing to run into at first glance. They do have a manual, as I mentioned briefly, so I'm going to take just a couple minutes and browse through this before I go too far, and I probably want to open the case and just take a sneak peek at the board. So the Tevo Flash, much like the Tevo Tornado, has an AC heated bed, and I also noticed that it's not sitting flat on the desk. This has been an issue with a couple of the Ender 3s as well, so we'll have to make sure we kind of square up this frame or adjust the feet, whatever is required to make that flat and not rocking. If we slide the bed forward, on the back we've got the cover for the board, likely on this side with a fan, and this cover is one piece all the way underneath this middle 2020. So we'll have to figure out how to open that up. They've decided to use, instead of a micro switch, they've got like optical switches here. Looks like for both the X-axis limit switch, the Y limit switch, and the belt is completely off the track. So there's an idler back here we'll have to reattach it to. And a very interesting routing for the belt, so we'll take a sneak peek at that as well. Let's open this cover and look at the board. So I tried and I gave up, but on this red cover here at the back, there are 1, 2, 3, 4 screws, black screws. I removed them. Sorry, 1, 2, 3, 4, 5. I removed them, and this cover was then suddenly loose. There's nothing connecting it to this middle rail. That's just kind of floating on top. But that cover wouldn't slide or move. So I undid all 4 bolts holding the black metal bracket part to the 4040 rails. And this entire thing wanted to slide out the back, which would have had the board mounted to the bottom of it. And it would only come out about 1 centimeter, and then it was caught on something. And I probably played with it for 15 or 20 minutes, and I still couldn't get it open. So I decided to button it all back up, and I'll have to take a look at that later. But the board, I could see the stepper drivers plugged into it right back there. So let's get assembling this. This comes in more pieces than I expected, because it appears like this is the DIY version, as opposed to the 50% assembled version. The 50% assembled version is a lot more like a CR10, where the entire gantry is pre-assembled and the stepper drivers and lead screws are already mounted and attached. This one, we have to build all of that ourselves, which is much more like an Ender 3 is. Inside here, there are the 2 lead screws. Let's get this open. Okay. And we may as well open these as well. So we're going to use, according to the instructions, M5 screws to attach a 2020 to the top. They're a little greasy. Maybe give them a wipe down. So we're going to have one 2020 with these pre-drilled spots facing up, and then the 2 uprights like this. We'll have this guy bolt in like that. We're going to be using the screws they call A01. They're M5 by 25 millimeter screws, or bolts rather. And they tell you to put washers on them. These lock washers, in my opinion, are optional. So don't do these up fully tight, just kind of snug enough that things aren't kind of sloshing around in there. And then we're gonna make sure that everything's as squared up as possible. Make sure that these ends are kind of flush and that these are square and not twisted. And then we will tighten everything down fully. So what I just did there was I placed it flat on what I know is a good flat surface, and I just pressed down so that all of this is now in line, so there's no twist there. And I have the bolts tight enough that they kind of held it in that position. And then I'm just going to tighten them fully now, making sure that things don't twist as I do that. There we go. So now we're going to place these components here, which the Z lead screw goes through these brass collars here. We're going to slide them on from the bottom. I'm going to place this one with the motor attached on this side. And then this one on this side. Now, if they don't slide on there with very little resistance, you may need to loosen the eccentric nut. There's an eccentric nut on the inside of both of these, but they slide freely, and actually there's almost a perfect amount of tension on them. So now we're going to take this entire assembly here and lift it on top of the base, making sure we don't crush any wires in the process. But there are little grooves cut out in the base that will slide right into. It It's quite a snug fit, which is actually kind of nice. Then you don't have to worry about things being out of alignment. They fit in there quite snugly. And then, as is typical, we're going to bolt through these side rails up and into the bottom of these to secure them. To do that, we're going to use these M5 screws. I think they call them A02. Yeah, those look good. These are quite a bit longer than the other ones. It's the only M5 screws that we have left, so that makes it pretty obvious. And the way I like to do this is just hang the printer slightly off a table, and then you have easy access to the holes underneath. And now we're just going to repeat the same thing on the other side, 2 more of the long M5 screws. And there's no reason to leave anything loose. There's very little play in this, so we don't have to worry about kind of straightening it up before we give it a final tightening. I'm just going to tighten them all the way right now. So before I go much further, I want to take care of this wobbling that there is in the unit. To do that, I'm going to take a similar approach to the ender. I'm going to loosen this cross member here that goes horizontally from the side rails. There's 4 M5 screws in either side. And then I'm just going to press down to hopefully kind of level the whole thing out. The other thing I noticed just now, as I kind of looked at all the items I unpacked from the box, is there's no spool holder again. This is something that I was kind of surprised by when I unpackaged the Tevo Tornado, that you're expected to print your own spool holder, which is a little bit inconvenient, especially if this is your first printer or your only printer. You have to jimmy rig something up to get your first print done. Well, that seems to have done it. There's no more wobble there. So now just make sure they're all tight. Much better. So now, referring back to the manual here, they suggest that we adjust these eccentric nuts, which, as I mentioned, they're already tensioned quite well. This one could use maybe a little bit more. But if I roll any one of the wheels on their own, all of them spin, and there's no play in them or wiggle. This one, the stepper, is just kind of flopping around in there, but other than the stepper, there's no play in the bracket or the wheels. I might tighten this just a little bit more once we've got the lead screws on them. And I'm leaving this stepper loose because we may actually have to take it off. I haven't got there in the instructions yet. So now we're going to assemble the X-axis gantry. That's this 2020. So this 2020 only has 2 large holes bored in the one end, as opposed to 2 on either side like this one. And those 2 large holes are going to likely go on this side. Yep, if you're facing the front of the printer, it'll be on the left of the hot end assembly. And at this point, they tell us to slide the hot end assembly onto that. So let's take a quick look at this hot end assembly. As I mentioned in the beginning, we have the BL Touch enabled version, and they used a authentic BL Touch. Yep, it's an authentic BL Touch right here, which is behind the hot end, behind the nozzle, sorry. And the nozzle is in a heater block that's kind of oriented like a volcano is. It's vertically oriented instead of kind of horizontally. And the BL Touch sensor is directly in line behind the nozzle, so it's not kind of off to the side at all. There's no X offset there. They're using 2 of these kind of typical cooling fans. There's no 3D printed parts here. This is all molded. It looks like it's actually quite an upgrade from the cooling that came on like the Tevo Tornado or CR10 style. So let's slide this on. And this is bidirectional. They're drilled the same on both sides, so it doesn't matter which way that's oriented. So at this point, we're going to attach the 2020 to the Z carriages. we're gonna start with this side here. We're gonna use the M5x8 screws. That's the smaller screws in the bag labeled A03. Yeah, A03. We're also gonna use the T-nuts, and these aren't hammer nuts. These ones have to slide into the rail here, into the extrusion. And they tell you to kind of slide them in the rail and then feed the screws into these carriages. Don't do that. That's a lot more difficult than it needs to be. So I would suggest that you feed the screws through. We're gonna start with this side. Feed the screws through. They go on the back side of here. Feed them out the front. And then loosely thread the T-nuts onto them, very loosely. And make sure they're oriented the proper way, so they should be tapered towards the front. Right? Do that for both, that one and that one there. And this way we're not dealing with the T-nuts kind of sliding back and forth in the extrusion, trying to line those things up blindly. And we should be able to, with any luck, maybe put some pressure on the back of the screws and just slide them in the extrusion like this. There we go. Cool. So now with that on there, around the back, there are the same holes through the back, and those lead to the screws. Just use those, slide your Allen key in there, and tighten those. Now don't tighten them fully, just until there's a little bit of tension on the T-nuts. Making sure you're using the right size Allen key would help, so that things don't slide around or fall off on you. And we'll come back and tighten those once we have the other side aligned. There. Okay. Put that down. All right. So we've got half of that assembled. Now on this side, you can see that these two little collars, little threaded collars, are going to slide into the holes on the back side of here. And this is why we needed to leave that intentionally loose. We're gonna need to, we don't really wanna flex it, but we're gonna loosen them a little bit more just so that we can get it over this hump. And then we will attach that there. There we go. And then I'm just gonna snug them up a little bit again. We're gonna use the other screws from this bag, the longer M5x15, I think they are, and the split washers, or lock washers, whatever you wanna call them. And we are going to bolt through these into those threaded collars. So I'm glad I left these a little bit loose because I had to slide the rail a little bit to your right to make those line up. And one more. So now that these two are through, I'm tightening them up fully. There's really not a whole lot of play in those. And this rail here should be flush with the anodized rail. That'll let you know that those are level. And then I'm going to go back and tighten up the two screws we put in earlier on this side. So now we're going to unpackage the dual Z-axis motors. Everything seems to be shrink wrapped pretty well here. There we go. The instructions told you to use M4 screws and T-nuts, and I couldn't find those, but they're actually already attached to the bracket in my case. So these are going to sit behind the 2040 uprights, here and here. And they've got the Z motor labeled cables there for them. So just turn the hammer nuts so that they're lined up with the slots. Slide that on there. There we go. And then I'll tighten that down. Making sure that the hammer nuts spin in the channel so that they're properly engaged. There we go. Okay, while I'm here, I may as well connect this. They really didn't leave a lot of slack there. There we go. And then the other side, same thing. So I've just unbundled all the cables so that I could plug this motor in. Here we have the X motor, extruder motor, and the X limit switch, which I mentioned is an optical switch. Now we're ready to take the lead screws, get all this plastic off them. We'll slide them down through these threaded sleeves there, and we'll have to attach the couplers to the Z-axis motors. There we go. I'm just rolling them on the table like that, some sort of flat surface, just to make sure that they're not bent or warped in any way. At least a quick check. They were packaged inside the aluminum extrusion, so if they're warped, it didn't really happen during transit. Okay, that should be fine. They should slide in without any resistance at all, and almost just under force of gravity, like that one, just slide right down to the bottom. So Tevo has included this standard spring coupler type to attach the 8mm, probably, threaded rod to the 5mm rod coming out of the stepper motor. And there's already grub screws in all 4 of the screw holes on the coupler, so you don't have to worry about those. So I'm just going to make sure that the grub screws are completely loosened so they're not stopping it from sliding into the coupler. Probably this one. Oops. And you don't want to just allow the coupler to fall all the way to the bottom and bolt it in that way, because there'll be very little holding on to this lead screw this way. It should be raised up a little bit. And then just tighten these grub screws down. And then we'll just do the same with this side. Now that we've done that, it's very likely that the X gantry is not level. By level, I don't mean level as if you stick a carpenter's level on it. I mean that it's not the same distance on this side as it is on this side from a point of reference like the top of the rail here. In this case, that side is clearly higher. So at the very least at this point, I just want to rotate these until it's at least reasonably close. And then later what I'll do is I'll measure from this rail up to, say, these brackets from here and here, and make sure that it's equal on both sides. So being the dual lead screw version, they've given us these 2 kind of toothed idlers. And these are for a timing belt that is going to synchronize the 2 together. What I mean by that is, just like I said, you're going to make sure that that's level. When you do that, you will have a toothed belt that is looped around both sides, making sure that if one moves, the other moves as well. There is a chance that with 2 different motors, especially if they're across 2 different drivers, stepper drivers, that they could become out of sync. Maybe one misses a step and the other doesn't. Now there's a bit of a tilt to that. And this should stop that from happening. That's the idea anyway. So these need to slide down on here, and we'll just kind of use the set screw to hold them for now. I'm not sure how far down these need to go. So not too tight, because we're likely going to have to adjust that a little bit. So it says to take the closed loop belt here and drape it just loosely over the two. Something like that for now should be fine. Then we're going to attach the top brackets that hold these screws stationary, and then we'll put the tension on the belt. So now we'll take these brackets that have a bearing in them, and these will sit like this. So it's a little bit cramped in there. There's two hammer nuts on the bottom here, and one of them is going to go between these two top screws that we bolted in earlier. And you'll want to make sure that the rod is right in the middle. It should be a snug fit. There we go. Okay. And then square up this top bracket with the front of the 2020. As you tighten them both down. Fix that a little bit. And then just repeat for the other side. With this side fully tightened, I've placed the bracket on top, and I've made sure that the belt is on either pulley, and the pulleys are actually loose so that this can all move. And I'm going to put pressure outwards while trying to keep the bracket square and engage the T-nuts. I had already pre-made sure that the T-nuts had rotated in the channel, and now all I have to do is kind of tension it and tighten it. I'll probably go back over this at the end and just make sure I've got adequate tension on this belt. This belt really just needs to be tense enough that the teeth stay engaged with the pulleys. We can move this up to the top here. Okay, so we'll leave that for now and we'll come back to that. So at this point, with the pulleys still extremely loose, I'm going to make sure that this is level. And the frame of reference I'm probably going to use is the top of the stepper motor. And I'm just going to measure to the bottom of these brackets here and make sure that it's equal height on either side. It's not exactly scientific because I'm not sure if I'm holding this completely level. 106. Oh, 3. So what I'm going to do is turn this collar here slowly to raise this side of the gantry until it's the same height as the other side. So now that I know that this is equidistant, I'm going to tighten the grub screws on there to kind of lock the two in place with respect to one another. So now the idea would be if I moved one side like this, the other side also moves. So before I flip it back around, the screws that go through these threaded collars here, they're just screwed into nuts and they're not like lock washers or anything. 2 of them were falling completely off the bottom of the screw. So just tighten those up a little bit. There's kind of a crush washer or a washer in between the brass collar and this bent plate here. And I'm not really like trying to tighten these down as if they're structural or anything, but just snugging them up a little bit. That nut was just about to fall off. Flip this around. Okay, so now we're gonna work on the gantry, X-gantry here a little bit. If I rotate both of the stepper drivers, or stepper motors, sorry. In this case, it's clockwise. I'll be able to raise this up a little bit. The hot end X carriage here is really loose. That's fine. We'll use the little stamped wrench to grab onto the eccentric nut on the bottom wheel and move it either direction. Just keep moving the same direction until it starts applying tension to the bottom of the 2020 rail or extrusion. There we go. And so now there's no slop at all. And if I move any wheel, they all spin. It's nice and smooth. There we go. There's quite a lot of oil on this rail, so I might give that a wipe down. Yeah. The other thing is the lead screws are dry. There's no lubrication there at all, so you may want to oil or grease those up lightly. So let's snip this wire tie here. We've got two B and C connectors. They've decided to use two sections of braided sleeve, one for the wires for the BL Touch and the cooling fan, at least on one side, the other for the hot end thermistor, cooling fan, and hot end fan, it seems. So I'm going to plug these into the back. One has 5 pins, the other has many more. And they only go in one orientation because they're keyed. And tighten this little collar just to make sure they don't pop out or anything. Okay. It's still a little disappointing to see that there is no strain relief on the 120 volt or 110 volt wires that are going to the AC heater on the moving bed here. So that's definitely something I'll want to print up for myself. So now we're ready to attach the X-axis timing belt here. So I've looped one side of the belt over right at the very end of the belt. There's plenty of extra length. And I've zip tied it to the back of the metal bracket in that slot. And so the belt is going to go over top of this pulley on the side here and continue under the rail. So get it situated on the pulley like that. And it stays under the rail, goes over top of where you zip tied it. At this point, it's teeth down. Oops. It would have been easier to do this as well before we had tightened the eccentric nut to give you a little bit more clearance, because you have to go over top of that bottom wheel in the groove. So once we've got it over there, now it goes over here, and then wrap it back around the back of the X carriage. And I've tightened the 3 screws that are holding the X-axis motor to the bracket. These screws are in slots, so you can use this motor to apply tension. Instead of the tension being applied by the idler on this side, as is normal, I'm probably going to need to get a 4th screw there, so hopefully I have a spare, because it didn't seem to come with one. At this point, I would loosen this motor, slide it all the way loose so that we have some space there to apply tension, zip tie the belt to itself onto the X carriage, and then loosen these screws and pull the motor out and retighten those to apply tension to the belt. So I've got the belt tensioned. I'm not sure that I'm a huge fan of this type of tensioning. It's kind of difficult to apply tension and tighten those screws. I kind of like wedging a screwdriver in here and putting pressure on the idler, but that's personal preference, I guess. And so now I'm just going to snip the belt pretty close to the ends on both sides. There we go. And so now that should spin pretty smooth. Good. Okay. So now I'll connect the X-axis motor just up on the back there. What else do we have here? We have the X-axis limit switch. So that is likely why there's that empty one there. And the extruder motor, which we don't even have attached yet. So that makes sense now. That's probably going to bolt right onto there. So in the bag labeled A05, there's an M3 screw that is for that X-axis limit switch. Slide that in there. And we want that to be as level as possible, really. Okay, good. So now we're going to bolt the Titan extruder assembly. Looks like instead of Palm or Delrin, this looks to be ABS, this large gear. And they didn't say that it was a Titan in this case. I know on the Tornado, I believe it says Titan designed by E3D or something to that effect. This just says Tevo. So we're going to use these long M3 screws in the bag labeled A04. There's only 3 of them, but we'll be using those to bolt down through the Titan extruder and into the stepper motor, sandwiching it onto this bracket here. And you'd want to orient this, you know, maybe something like that so that the wires are going out the side. And 1, 2, 3 screws down through the top. You want to make sure these are snug, but I wouldn't go too crazy on them. So one thing that I found on the Tevo Tornado, which they seem to have fixed with this design, is they've shifted the extruder out a little bit. So now you can get at the screw tensioner for the spring here. Before it was kind of right beside the upper extrusion there. So that's kind of a nice small improvement. And because of the orientation of this, where the filament goes in here, it's kind of blocked by this lever, which is for the tensioner there. So that we don't have to print a guide or anything to stop the filament from rubbing along the lead screw like you do on a lot of the other models. So that's kind of a nice small design change there as well. Since I've got this here, let's tip it sideways. The Y-axis has an interesting belt arrangement. So the stepper motor is right here, and it has 2 idlers there, an idler here and another one at the back. You can also use this front bracket there to adjust the tension. That's kind of interesting, and it is very cumbersome, kind of, to get the belt to stay on these idlers. This unit actually came with the belt all detached, and I spent a little while. The shoulders on the idlers are not very high, so the belt has a pretty easy time slipping off if things aren't aligned absolutely perfectly. So I didn't see it mentioned in the manual at all, but obviously we need some way to get the filament from the extruder at the back here to the hot end there. So I'm going to recut this with an X-Acto knife because it's not exactly square. And a sharp blade like this, or an X-Acto knife or razor blade, works better than snips because it doesn't crush the PTFE tube as you cut it. So make sure that's as square as possible on both sides ideally. Slide it in this collar here. And there's a little plastic guide in there that goes right up to the extruder gear. So it'll stop when it won't go any further there. And this is probably way longer than is needed. Yeah, it's not bad. This is going to go a little ways down into the hot end, I bet, so we'll leave that at that length. Square this one up as well. That one was on quite an angle. There we go. I'm kind of pulling up on the hot end as I push down. I don't want to just put force down on it like that. Okay, that seems to be about as far in as it's going. It's kind of slippery. I'll have to do. Okay, and so I'll probably take the rest of the zip ties and attach this up here. There's an empty hole on the bracket by the extruder where the inlet for the filament is. So I might use the underside of that to zip tie the looms here, and so that they come off to the side like this and don't get caught on the bed as it moves back and forth. And we'll be back when that's done. All right, so I've done some cable management and I've tidied up my workspace just a little bit here. There was no mention of them in the manual, but the toothed idlers that we attached for the Z lead screw synchronization belt there came with these two little rubber grommets or washers. I'm not exactly sure what they're for, but I don't really see a need for them anyway. And of course, we've got your typical assortment of extra bolts. There's a small M5, maybe by 10, a larger by say 25, and then another huge one from where we bolted underneath the frame and attached the uprights. So don't be alarmed if you have a couple extra things there. We've also got a whopping 512 meg full-size SD card. So the full-size SD card goes right here. And you can actually see the back of the board and everything there. It's open at the back. The same kind of knob as is on the Tevo Tornado. So let's plug it in and check the mechanics. So that clicking you hear there is the BL Touch. That gets activated when the machine turns on. Tevo Flash version 1.0. So it's kind of a small screen. It is black and white. It's a little higher resolution than the Tornado had or the CR10, but it definitely is a little bit on the small side. So you can see the temperature sensors are working, 24 degrees on both. That's the temperature in the room here. And let's do a bed leveling. Actually, let's just move the axes independently first. So let's try homing the X. And you can see the light on the X-axis limit switch engaged. When you home the axes for the first time, you might be well suited to keep your finger on the power switch in case one of the end stops or limit switches don't work as expected. But it kind of bounced off the X and then homed itself. If we go back to prepare and home Y, it's already basically home. Let's move it forward. Okay, one thing we haven't done is check the eccentric nuts on the wheels for the Y-axis to make sure that this isn't flopping around, and there's quite a bit of play in there right now. So we'll take a couple seconds and check that. Let's go back to move axis. Let's home the Y. So interesting. The Y-axis limit switch is engaged right now. It's lit up, so it thinks it's already at the back. So when we home Y, it just bumps itself to the front a little bit. Not sure what that's all about. So you'll notice there's no Z-axis limit switch on either side, and there's no cable for it. And that's because the BL Touch acts as your Z-axis limit switch now. I wouldn't suggest in our case doing a home Z because it doesn't know where the bed is. It thinks the bed is homed right now as the limit switch for the Y is activated. So it's probably going to try to move this to the center of the bed and home the Z. So I need to figure out why my y-axis limit switch is essentially inverse of what it should be. It's engaged right now, or it's constantly engaged, it looks like. Unless I can get into the box, as I mentioned earlier, I had a hard time getting the cover off and getting access to the board. Maybe I can see how this is wired up or replace the sensor, but it didn't come with any replacements, so I'm going to have to acquire that on my own or contact Tevo. But it seems like this sensor is either inverse of what it should be or defective because it's constantly sensing. I think I also referred to these as optical sensors over and over. These are inductive sensors, not optical. So they don't sense, your finger, they sense typically steel, ferrous metals ideally, but they'll also sense aluminum. In this case, it's sensing it constantly, so it'll probably have to be replaced. As a result, I'm not going to be able to use the printer. It thinks that the y-axis is always at the back, at 0, so unless I move it to the back and zero it that way, it's never going to actually know. So I'm going to fix that before I play with this much further, but that's a little bit disappointing for a product right out of the box. Anyway, remember to like and subscribe and stay tuned for the fix for the Tevo Flash, as well as our first prints. Thanks for watching.